Hello. In this video we're going to go over 2008 AP Calculus for response question 3, part A. So in question 3 we're told that oil is leaking from a pipeline on the surface of a lake and forms an oil slick whose volume increases at a constant rate of 2,000 cubic centimeters per minute. That tells us that dV/dt, the rate of change of our volume with respect to time, increases, so it's positive, 2,000 cubic centimeters per minute. Then we know the oil slick takes the form of a right circular cylinder with both its radius and its height changing with respect to time. And we're given the formula for volume of a cylinder. Volume is pi r squared h. Let's see, in part A, we're asked at the instant when the radius of the oil slick is 100 centimeters, I'll write that down, the height is half a centimeter. Let's see, when that's happening, the radius is increasing at the rate of 2.5 centimeters per minute. So that means dr dt, the rate of change of the radius is increasing, so positive 2.5 centimeters per minute. At this instant, what is the rate of change? Let's see, what is the rate of change of the height of the oil slick? So what that wants, it wants us to find dH dt. And if you prefer H prime, that's fine, or over here if you prefer V prime or R prime, whatever notation best fits you. So what we're going to do is we're going to take this volume formula and take the derivative with respect to time. So if I take the derivative of volume with respect to time, I get dV dt or V prime. And then when I take the derivative of volume, I'm going to use the product rule. So I'm going to do 1 d2, so derivative of h is dH dt. 1, well, the derivative of h is 1, but since we're taking the derivative with respect to time, it's dH dt. So 1 d2 plus 2 d1. So the derivative of pi r squared is 2 pi r dr dt. All right, now what we're going to do is we are going to solve for dH dt. So I'm just highlighting it so you know what we're looking for, and we're going to plug in everything else we know. So we know dV dt is 2,000, and then we have pi r squared, so pi times 100 squared, times dH dt, which I'll make another color so you remember that's what we're looking for, plus h, the height is half a centimeter. You can use a fraction or you could use a decimal, whatever you prefer, times 2 times pi times the radius times dr dt, which is 2.5. And put grouping symbols where you want. I kind of put them all over. And then we are going to solve for dH dt. And I can simplify if I want, like I can do half of 2. I can multiply, but I don't have to. So then what I'm going to do is I'm going to move all of this to the left side. So I'd end up with 2,000 minus, I don't know, 100. I'm not going to simplify so you realize you don't have to. Times 2.5 times pi. And then what I'm going to do is I'm going to divide by pi times 100 squared. You can simplify if you want, but if you mess up, you lose your points. Now, we're looking for the rate of change of our height. Height should be like radius, where our height is changing in terms of centimeters, and since dH dt is a rate of change of your height, it's centimeters per minute. And right here, I would say this is our answer. Let's check the rubric. Way down there, sorry. So if you were able to figure out the rate of change of the volume is 2,000 and your rate of change of your radius is 2.5, you get a point. I'll kind of shrink this up a little bit if it lets me. Nope. If you actually came up with this expression over here, By doing the product rule and implicit differentiation, you get 2 points. And then if you get your answer with the unit, of course, make sure you have the unit, you earn your other point. That's it. I hope you enjoyed.